Hello everyone. In this video, we are going to discuss about how to calculate array address of a double dimensional array. So it comes in an ISC board examination in the compulsory, that is part 1. Okay, it will be a 2-mark question, so you have to know about it so that you can easily attend the question. While storing the elements of a 2D array in memory, these are allocated contiguous locations. So elements are stored in a sequence or in sequence order, maybe in row wise or column wise. That's what it means. The 2D array must be linearized so as to enable the storage. So you have to make it. So normally when you say 2D array, you always think about matrix. Okay, but it should be linearized to store the values. So you have to either go for two alternatives. Other one is row major or column major. Either you store row wise or column wise. That's what it means. This linearization technique stores firstly the first row of the array, then the second, and then the third. It goes on like that. So that's what we meant. Whenever you store any elements in an 2-dimensional array, you will go row wise, storing the first row. After completing the first row, you will go with the second row. So it go on like that. So logically, the implementation will look like a matrix like this. So you can see rows and columns, and you will have the row address and the column address for each cell. Okay. So for example, A of 2, 1, you can see locate the position here. Now physical row major implementation look like a single dimensional array where you will have row, first row, then the second row, then the third row. It goes on like that. So if the element is want to be located, you can see that 2, 1 has been located. It is second row and first column. Okay, it goes on like that. Now, if you know that address of the array will be stored in the memory, but the computer does not keep track with all the address of the elements in the array because it got lot of data available. So what it does is it will keep track with the base address. That means the starting address of the first element, very first element. So once it knows the first element's base address, you can calculate the address of the remaining cells. That means you can locate the other elements easily. So for calculating the address you need a formula. So address of ijth column. So if you want to suppose locate, you know the base address, you want to locate the address of a particular element. To retrieve it, you need a calculation. That is, you need a formula. That is b plus w, and then you got a bracket. Okay, open bracket, where you have c into I minus lr plus j minus lc, and open and close bracket. That is, you have to close the bracket. So this is the formula. We will explain you the formula, and you are going to discuss each and every character. So first character you go for it is b. B is nothing but the base address. So it will be, see, once you give a question, you have to go through all these words available, and then you can replace it with the character. So B is the base address. W is the element size. So it will be given as a question. It may be integer element, it may be a double element, it may be a character. So according to the element size, you should know the word size. Next is LR. LR is nothing but the first row and first column. That is LR and LC. First row number, first column number. And then you can see I and J are the values of the address you are going to find. Okay, you are going to calculate some address, right? So that will be the I and Jth address. So I and J are nothing but the row and column for which you are going to find the address. And then you got C here. It is nothing but number of columns. So you have to notice one thing. You got C into I minus LR, because since it is row major order, you are going to multiply with the column, okay, number of columns, and then you are going to multiply the value, that is I minus LR. Okay. Then you can see some cases you may see a range of values. So you will be given low and high value. That is, you will be given the first row number and the last row number. Okay, lower column and upper column. So in that case, what you can do is you can write upper column, that is UC minus LC, that is lower column, plus 1. Okay, so we will be discussing it, and that will be the column, number of columns. So you are going to see one question, okay, to explain this. A 2D array defined as A 4, 2, 7, minus 1, 2, 3 requires 2 words of storage space for each element. If the array is stored in row major form, calculate the address of A 6, 2 given in the base address as 100. So you can easily say that base address is given here. 2 is the W value, and then you have you can see that LR, that is LR is nothing but 4, that is the first element, row element, and then LC is minus 1, you can see minus 1 here, so that is the lowest, that is first column. Okay, and I and j value, so I and j value is the address you are going to calculate, so that is 6, 2 is the I and j value. Now the C value should be calculated. Since it is given range of values, you have to calculate it. So you can see here UC is nothing but the upper limit, that is column. So 3 is the upper column, and then minus 1 is the lower column. So LC is minus 1. So you can see here UC minus LC plus 1. So you can see 3 minus 1 plus 1. Okay. So when you calculate it, it will be minus into minus, it becomes plus. So 3 plus 1 is 4, 1 plus 1 is 4 plus 1 is 5. So that is the column value. Now you got all the values here. Now you are going to write the formula and substitute the values in that. So you can see B, base address is 100. Then you have W, that is 2. Then you got C, that is 5. Then I value is the row which you are going to find the address, that is 6 minus 4. So LR is nothing but minus 4. Then plus 2 is the J value minus, and then LC is minus 1. So 2 minus 1. So this is the substitution. Once you do the substitution, whatever is given in the inner bracket has to be calculated first. So 6 minus 4, it is 2. So 5 into 2 plus 2 minus 1. So minus into minus is become plus. So 2 plus 1 becomes 3. So that's what you got inside the parenthesis. Now again, next step you can see you have to multiply this bracket. 2 into 5 into 2 is 10. 10 plus 3 is 13. So that is what you get in the bracket. And then you have to multiply the W value with that. So it becomes 26. So 100 plus 26 is the final one. And then you add these two, you will get 126. So 126 is the address of 6, 2. Okay. So this is how you are going to calculate the row major order. That is the. You will see one more example. X is 2D array, 10 cross 5. Each element of array is stored in 2 memory location. If x 1, 1 begins at the address 150, find the location of x 3, 4 use the formula for calculation. The arrangement is in row major order. So you can see the words are changed here. So but when you read it, you can easily locate all these elements. So one is base address. So which is the base address? You can see that x 1, 1 begins at the address 150. So this should be the base address. So 150 is the base address. So B equal to 150. Now element size is W. So you can see here the element of the array is stored in 2 memory locations. So you can see 2 is the W value. So W equal to 2. Now you are going to find the lowest row and lowest column. You can see x 1, 1 begins at, that is the beginning value, right? So this is the LR and LC value. So LR is 1, LC also is 1. So LR equal to LC equal to 1. Okay. Then you should know the I and J value. So you can see find the location of 3, 4. So this should be the I and J value. So you got I equal to 3 and J equal to 4. Then finally you need the column value. So column value here you can see 10 is the row and the column, that is 5. So this is the maximum value which can be stored, right? So you have got the column value, that is 5. So C equal to 5. Now you have to write the formula and then substitute the value, that is 150 plus 2 into 5 into 3 minus 1 plus 4 minus 1. So first we complete the innermost bracket. So 3 minus 1 is 2 and then 4 minus 1 is 3. Then again you calculate the outer bracket. So it becomes 5 into 2 is 10 plus 3 is 13. So 150 plus 2 into 13. So 2 into 13 is 26. So 150 plus 26 is 176. So this is the final answer for this question. The same way you can also find the row column major implementation. This linearization technique stores firstly the first column, then second column and so on. So when you store the element, you will go for column wise. So column 0, column 1, column 2, it goes on like that. So you can see the data is located 2, 1 is located here, okay, which has been marked here. The formula for array calculation is same, exactly same, only difference is you can see previously in row major order you use the column, here you have to use row but multiply with J, LC, okay, that's what you are going to do. I minus LR will be the same, but you have to take the row, okay, you have to find the row and then multiply it with J minus LC. That is only difference in these column major and row major. So you are going to see an example. Each element of an array A minus 20 dot 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 20, that means the range, comma 10 to 35, requires 1 byte of storage. If the array is stored in the column major order, beginning at the beginning location is 500, determine the location of 0, 30. Okay, so the values has to be found. You can see the beginning location, that is base address, so B equal to 500, and the byte, you can see, requires 1 byte of storage, so W equal to 1, and you are going to find the LR and LC. So you can see the least row is minus 20 and least column is 10. So LR equal to minus 20 and LC equal to 10. Now you are going to find the I and J value. So you can see you are going to determine the location here. So that is of 0 and 30. So R is 0, sorry, I is 0 and J is 30. Okay, that's what you got. Now here again you got a range. Okay, here you are going to find the row value, right, number of rows. So what you can do is you can write UR minus LR plus 1. Okay, that is the formula. So UR is nothing but 20 minus LR, that is minus 20 plus 1. Okay, so 20 minus 20 plus 1. So minus and minus will be becomes plus. So it becomes 40 plus 1, it is 41. So 41 is the row size. Okay, number of rows. Now you are going to write the formula. Okay, so remember this is only difference, R into J minus LC. Okay, that is only difference with column major. Now you are going to substitute the value. So 500 plus 1 into 0 minus 0 minus 20 plus 41 into 30 minus 10. So inner bracket has to be calculated. So this minus into minus becomes plus, you will get 20, and then 41 into 30 minus 10 becomes 20. So you will get 41 into 20. Next line you can see 500 plus 1 into, you are going to multiply this for 41 into 20, it becomes 820 plus 20 becomes 840. So multiply by 1, it becomes the same value. So 500 plus 840 is 1340. So that is the answer for this question. So we will see another question which came in the board examination, but I have taken this question so that you are not only going to calculate the address of an element, you may calculate something else. For example, in this question you are going to calculate the size, element size. Okay, so we will see how to calculate by using the formula. Each element of an array ARR 15, 20 requires W. So you can see W is given, no values are given here. So that means you are going to find this. So W bytes of the storage. If the address of ARR 668 is 4440, that is 4440, and the base address at ARR of 1, is 4000. Find the width W of each cell in the array ARR, that is open and close brackets, when the array is stored in the column major order. So this is what you are going to see. You are going to calculate in column major order. You are going to take the values one by one. First one is you are going to take the base address. You can see base address is already given here, so it is 4000. So B equal to 4000, and W width size has to be found. So you have to just write W as it is, and then you are going to find the LR and LC. LR and LC is the base address row and column values, that is 1 and 1. Okay, so you can see base address at ARR 1 and 1, that is the LR and LC. So you have to write that. So LR equal to LC equal to 1. Both are 1. Now you are going to find the I value and J value. So you are going to already, you can see that address of the element is given, that is 6, 8 is given here. So I value is 6 and 8, J is 8. And 4440 is the address you found. So you have to write it as it is, and the row value should be found. So this is the row value, that is 15 is the row value. Okay, directly given, you have to use it. So all that elements has been found. Now you are going to substitute with the values. So B plus W, okay, that is the formula, I minus LR plus R into J minus LC. Okay, so here you already got the address value, that is for the element 6 and 8. So you have to write in the left hand side. So 4440 equal to base address, that is 4000 plus W into 6 minus 1 plus 15 into 8 minus 1. As usual, you are going to calculate the innermost brackets. So this 6 minus 1 becomes 5 plus 15 into 8 minus 1 is 7. Okay, so you got this. Now you are going to calculate the outer bracket. So here 15 into 7 and then plus 5 becomes, that is 15 into 7 is 105, plus 5 is 110. Okay, so this is what you got. Then you are going to take this 4440 towards this right hand side, and W you are going to take it to the right left hand side of the equal to sign. So once you do that, what happens? It becomes minus W of 10, that is 110 equal to 4000. This becomes minus, right, negative value, so minus 400 and 440. So when you subtract it, you will get 440, that is minus 440. So see, since you got minus and minus both the sides, you are going to cancel that. So you can write W equal to, you can bring this 110 towards this right hand side after equal to sign, so it becomes, multiplication becomes division. So 440 divided by 110. So these are all basic maths you already learned. Okay, so once you do that, you will get 4. That is the answer. That's 4 byte is the value of W. Okay, so this is how you are going to calculate the array address calculation for double dimensional array. Hope you understood this calculation. You can try out more questions in the board examination, so you can practice your get ready for your board examination. We will meet in the next video. Till then, thank you.